Alternating current put out by the AC generators goes through heavy-duty electric cables to a special device called a silicon-controlled rectifier, or SCR. The SCR converts AC to DC. Other heavy-duty electric cables carry DC electricity to the DC motors. The DC motors convert electrical energy back into mechanical energy to drive the powerful hoisting, rotating, and circulating equipment. Rig owners like to use AC generators because they can be built to be very powerful for their size, which is an advantage over DC generators. Also, rig equipment can distribute AC easier than DC. But direct current has certain advantages when driving large equipment. Mainly, DC motors produce a lot of torque at low speed that the drillers can easily control. Using remote switches on his console to control the SCR control panel, the driller can select and deliver the power from the various generators wherever it is required. But some AC generators power big motors. In fact, most of today's diesel-electric rigs use AC generators in a system called an SCR power system. Here, a large AC generator, an alternator, is connected to the diesel engine prime mover. As the engine mechanically drives the AC generator, the generator produces alternating current, or AC electricity. AC is like the electricity used in most cities and homes. Remember, an electric generator, or alternator, takes mechanical energy and creates electrical energy. An electric motor does just the opposite. It takes electrical energy and creates mechanical energy. Equipment in this electrical cabinet converts, or rectifies is the electrical term, most of the AC current produced by the AC generators into direct current. As mentioned before, rig owners usually prefer DC current for driving the very large equipment that requires precise variable speed control and high torque. The control equipment includes solid-state electrical components called silicon-controlled rectifiers, or SCRs. Heavy-duty electrical cables come out of the cabinet and carry DC electricity to the powerful motors driving the circulating, hoisting, and rotating equipment. Usually, large DC motors supply power to the mud pumps, the drawworks, and the rotary table or top drive. Sometimes, the drawworks mechanically drives the rotary table, but on some rigs, the rotary table has its own motor. The driller can control the speed of a DC motor very accurately, which is why rig owners use DC instead of AC motors. With accurate speed control, the driller can accurately set the speed the drawworks lifts, the mud pump operates, and the rotary table turns on rigs without a top drive. Various small components on a rig need power too. For instance, these two centrifugal pumps move mud from a tank to supercharge the intake of the mud pumps. In this case, it's more efficient to use small motors to power the centrifugal pumps rather than using the prime movers, hydraulic fluid, or air. Here's another AC motor. It powers the paddles on the mud agitator in a mixing tank. AC motors generally power equipment that does not require a lot of horsepower. So they vary in power from less than 1 horsepower, or 0.75 kilowatts, to more than 150 horsepower, 100 kilowatts.